Perhaps the most important functionality in Google Colab is to be able to execute Python code. And for that, we have these code cells. So for example, in this cell, and we see that it's a code cell because it has also display here. So we can, for example, print hello Colab, and if we press this cell here, or we press Ctrl Enter, it will execute this Python code in this cell, or we can also press Shift Enter. This way it will execute and create another code cell for us. So we're executing this print hello Colab. It's connecting to the kernel, initializing, and then executes our hello Colab Python code. It is important to have in mind that your Python programs, when you are using Google Colab, for example, for development purposes, it will be executed in the order of the execution of a cell. So if you are perhaps doing many modifications and you go back to one cell and then you execute some code and you lose more or less the order in which things are being executed, you can end up with different results, not as expected. To demonstrate this, we can, for example, have a counter, and we will try to update this counter value, but this counter still wasn't defined. So if we run the cell, we will end up with an error because counter is not defined. But now if in the next cell we define counter equals to 0 and we run this cell, now we go back to this cell, there is no error anymore. And if we go up here and we see print counter, we see that it's been updated. Now we will run this once again. So it really depends on the order that you execute the cells and not on the order that the cells are displayed here. So this is one very important thing to have in mind. And usually if you are using Google Colab environment to develop something, it's very important that you keep in mind and try to execute the cells in the correct order. And if you do some modifications, you always have this in mind, otherwise you can have some problems. And it seems everything is working perfectly, but once you reset your environment, or if you open your notebook and another time and you try to execute in the same order that the cells are displayed, but you did something different the previous time, you may end up with different results. In Google Colab and in general in IPython, we can also execute shell commands or terminal commands by using this operator exclamation mark. So for example, and then we want to see the files in this current directory. So we see that there's a subfolder called sample data. We can also see what's inside this sample data. We cannot access this here, sample data, and we see the files that are inside of this folder or directory. So this operator can be very useful when you want to run shell commands inside your Google Colab notebook. Not only we can execute shell commands, but we can also get them. So for example, we'll use a variable called content, and this variable will be equal to, use this operator, and then we get the files from this sample data directory. So now we have this content that it's kind of a Python list with the files that are the file names that are inside this simple data directory, but have in mind that this is not a simple Python list. So the type of this variable now is an IPython utils text as list. So this is a special kind of a list, and we can see how to use some special functionalities containing in this special list if we, for example, call for help on this content. We see here that this is as list in the module IPython utils.text. So this is a list, a derivative with special access attributes. So it's normal lists, but they have special attributes. Value as lists, value as strings, and we can, for example, use this to find items in this list. We can use like grep to return string matches, strings matching some patterns. We can use sort and other things. So with this help, you get all the functionalities added to this special kind of list. We can, for example, use this content kind of special list, and we will use it with grep, and we want to see the contents that starts with C, for example. And here we have this California housing here. As we can see, these two files, they are separated by a space, but they are considered one element in this list. As we can see, this is one element of the list, this is one element of the list, this is one element of the list. The same if we see, for example, element 0, have these two here, but we can also have things in separated, for example, as strings. So you can manipulate these items in this list in different ways. You just need to understand what's going on. But it's very useful to use this operator to execute shell commands. But have in mind that we cannot change directories using this command here. Suppose we would have, let's make a new directory. So now we have this new directory called test, but we are in this app directory here. So if we see here, we will have this two. If we would like to go inside test and do something like this, we see that it doesn't work. There is another special way to do this that we are going to discuss later, which are magic inline commands or magic cells also. But for example, if we would use this now we are in a different directory. So we cannot use this operator, but we will use this other operator to, for example, change to another directory. So, as we already seen, there are more enhancements, tools to make our life easier using IPython and also using Google Colab, which are magic commands. We can have magic commands or functions, let's call also, and we can have an inline command that will execute this command, or we can have that the whole magic will be applied to this cell, and everything that we, for example, if we use HTML, now this cell will become an HTML and it will render HTML code. So these are very useful ways to execute some code and to automate things, or to make just life easier in general. An interesting magic function is a function that, for example, will time certain execution. So we have this time it here, and it will execute this operation here. So we're creating a list with n squared for n in range from 0 to 1000, and it will execute, and it will give us that it take 1000 loops, and it's 263 microseconds per loop. So if you go, for example, to the IPython documentation and you look at the built-in magic commands, for example, you will have an explanation of all the inline magic commands that are available, and also the cell magics like I explained before. And have in mind that these magic commands, they are not the same for all the different kernels, and also I'm not sure if Google Colab implements all these magic commands, and perhaps Google Colab also has some special magic commands. So you need to look at the documentation and see which are the magic commands that are available. So we've seen here the line magic commands, and we also seen before that we can change the cell. So this is a cell magic command, and now everything what we do here would be rendered as HTML. So for example, let's have here a table. We have here this HTML table, for example here. So we do this, we are executing all the cell as if it would be HTML, and here you also see all the cell magic. So we can use a bash script magic that runs cells with a bash in a sub processes. We can use capture that run the cell and capture the std out and std err, and IPython's rich display calls. We can execute a JavaScript code. We can use latex code. We can render cells as markdown. We can execute Python scripts, Ruby scripts. So there are many interesting things. We can write contents of a cell to a file, for example. So imagine we would have some Python code here. Let's say this print hello, but now we want to have this cell write into a file. Write file, and then we will give a file name. So this will be test.py. Okay, so now we see that we have our test.py inside this test directory, which is the we are now. And we can also, for example, use the exclamation mark operation to run certain Python scripts. So for example, Python 3 test.py, and we have hello Colab. We can also, as in a text cell, but we can also transform this cell now to a latex cell. So for example, if we now, everything what we will do in this cell would be rendered as latex. So this is matrix, for example. Give some space here, and when we execute this, we have this nice latex display of this code here. In case you need to use some Python 2 code, you can also make this cell into a Python 2 cell. And if we now, for example, in Python 2, we don't need to use brackets for the print function. So let's see if we will try to use without the brackets, we will have an error because the code cells, they are Python 3, but here we are using this magic command and we're transforming this cell into a Python 2, so it will execute this code in a Python 2 way. One example, using a JavaScript, we can define some variables and add them and display in the console. So when we look at the console, you will see here we have the result 11, 5 plus 6, the variable z, and we are displaying the console this variable z. So have in mind that there are also limitations. It seems that every HTML code and JavaScript code for itself is executed in an individual iframe, so probably you won't be able to communicate between these two cells. So for example, if you define a button in this cell and then you want to use this button to access another HTML element, may not be possible, but you can also read at the JavaScript documentation of Google Colab. So basically we've seen how to use the code cells with Python code, and also these tools like how to execute shell or terminal commands. We've seen the line magic commands or magic functions, and the cell magic commands and magic functions, and also we've seen how to use, for example, latex cell magic cell command, JavaScript, HTML, how to write a file, and those things makes this Google Colab also very powerful for using all these different tools available and combining LaTeX with HTML with JavaScript and take more advantage of all the possibilities that are available. Another interesting thing that we can do with code cells is to, for example, show or hide the code. So now we're hiding the code and we're just seeing the output of the cell. We can show this code, and we can also show or hide the output. So now the output is hidden, we just see the code. Here we see the output. So sometimes you also want to make a presentation, and if you want to make things less confusing for the person who maybe is not used to write code or to program in Python, and you just want to display the results of your research, and you can simply hide the code, and then you will have more clean view, and if the person wants to see the code that was used to generate these results. Maybe later on I can go in more detail on the specific things, more, let's call, advanced output to combine JavaScript specifically for Google Colab, because not everything works as if you were using JavaScript normal browser environment. There are certain things that the way that Google Colab is built that may limit, but they usually provide some workarounds, but you need to know these details. But already with this you can execute your Python code, you can use these shell commands and also use these magic functions, and you already can achieve a lot with these tools. Finally, I will show an example combining both the text cells and code cells, using also magic functions, using shell commands, having interactive plots. So this is a tutorial that I have on my GitHub and on my YouTube channel. It's about the basics of pitch estimation, automatic music transcription, that you find at Guitars AI GitHub at the basics of automatic auto transcription repo. So you can copy this address here. When you go to Google Colab, you can enter here this address. So you can select this notebook, and we will have here the same what I have here. Unfortunately, this was not made for Google Colab, so I used the normal Jupyter notebooks in my own environment. Defined here also in this environment, so are all the libraries that you need, and some libraries they are not pre-installed in Google Colab, so we need to make a few modifications to run. But here, this is a text cell, and I'm displaying an image here also. So this is how we would use in HTML. I can display some image here. Then here now I'm installing the MIDI-util library in MIDI Pygame, which actually is not necessary if you run this example here, but as you can see in the original file we don't have these cells, but I had to include here, otherwise it would not run. So you need to install MIDI-util. Here I am cloning the GitHub, so I have all the files that are on the GitHub, especially here the audio that we're going to use. In this example, we will make the automatic music transcription of the introduction of Guns N' Roses' Sweet Child O' Mine. So we need this WAV file here. And after I clone, I will create this directory and we will have our file here. So this is what I'm doing here. Here we can see an example. So I am displaying a YouTube video. So you go through this notebook and you can watch the video with the explanations. I go through the code, I explain the theories. Hi guys, I'm Farah from I explain the signal processing behind it, the audio programming techniques. So I'm including here embedding on YouTube using the magic cell. Then I'm importing some libraries. Here is another difference that you need to change. This was a generic path that we had here for my environment. If you configure to run locally, not using Google Colab, but now we need to include the path where this audio file is. So it's the content, then goes to this subfolder, this subfolder, this subfolder. So we need to make this modification here. Then I'm defining some parameters. Here I'm loading an audio file, and here we can play it back. Recognize the song. It's just the introduction. It's a WAV file. What we're going to do is we're going to generate a musical score from this audio file. We will also generate MIDI files. So it's kind of, let's say, we'll convert this into a MIDI, and it will also generate sine waves that will play it back. So it's kind of a synthesizer, so it will convert this into sine waves. Here I just give an explanation about some techniques. So it's the constant Q transform, and we have a plot showing. Here I explain the difference between the constant Q transform, the fast Fourier transform, the relation to musical notes. Here we have some functions to calculate these transforms. I again embed some videos. We calculate the onsets, which are kind of detecting where the music notes start and the duration of the music notes. So the CQT will be the part where the frequencies of the notes and the notes name. So here we'll have a GUI, so it's an interactive. We can fine-tune. So I already defined all the parameters, but we can fine-tune. So each one of these red things here are some notes, and these lines are where they stop and they start. But we can, for example, change here some parameters, and it will automatically update plot and update our program. So then we estimate tempo, we convert seconds to musical duration, we convert into MIDI more tutorials explaining. I go through the code, I'll go through the theory, and here is the result after we do all this process and we get, let's say, from this audio, this raw wave file, we get some amplitudes and frequencies and duration of sine waves, and we can play it. We can also get the key. It will automatically analyze the notes that are in this part of the song and tries to tell which key it is, and then it will give you some notes with the time they should start. If you are running locally, you can also display automatically the musical score, but it's not possible here with Google Colab because it uses a separate software which is called Music Score, and use this software to generate the score. And I didn't find a way how to install software and run in Google Colab. I'm not sure if it's possible, but if you run locally, so this point here, we will open this music score and it will display also this MIDI file with the musical score. So we are generating here music. Here we have these MIDI files that were generated here. So I can, for example, go to the music score and I can open, and here it is, the musical that was generated using Python. We can play. It's not perfect, of course. This is a very difficult task, especially if you're dealing with more complex songs, instruments playing on top of each other. So there are many researchers and scientists working on this problem of automatic music transcription. This is just the basics, then the fundamentals, and actually I'm just showing here how we put everything together, and we put magic cells, and we put text cells and code cells and Python code, and we can have some nice applications such as this here that will extract musical notes and duration from an audio file, and then we will have a MIDI file out of it and musical scores out of it. So this is something very powerful which you can also achieve with Google Colab and Jupyter Notebooks. And that's it. I see you next time. Just as a side note, I just remember that there is one more thing you need if you want to try to run this. There is another difference, that Librosa, the version that is installed in Google Colab, it's using this character here for musical accidents, like the sharp, instead of the normal sharp on the keyboard. So the Music 21 library that I'm using doesn't recognize this character. So unfortunately, on previous versions of Librosa, this didn't happen. But as I mentioned before, Google Colab comes pre-installed with some libraries and different versions maybe than the one I used, such as in this case. So I have to replace here this character by this, and then you will not find it here on the original file. There is just a MIDI note, but here we have to replace this. So this is one more thing. You may try to run this notebook in Colab. If you don't do these modifications, if you just, let's say, import it from GitHub, it will not work, and you need to start debugging it and finding out what are the problems. And you'll see that you need to install some libraries, and you'll notice that maybe this is a common problem in Python, that sometimes libraries change and they are not compatible with previous versions, or they change something that really destroy your project. So you need to be aware of the versions of libraries that you are using. But this, if you do some of these modifications, it should work.